Why inelastic buckling is a common failure mode. Imagine a tall, slender column standing quietly under a heavy load. Suddenly, it bends and collapses unexpectedly. What caused that? It's often inelastic buckling. This failure happens when a structure is pushed beyond its elastic limit but before it is crushed. When materials yield, they deform permanently, weakening the structure. Unlike elastic buckling, where the structure springs back after the load is removed, inelastic buckling involves plastic deformation that stays. This makes the member weaker and more likely to fail at lower loads than simple elastic theory predicts. Many columns or compression members in real-world structures fall into a middle ground called the intermediate slenderness range. These members are not so short that they just crush, but not so long that they buckle elastically. Instead, they tend to buckle after some yielding has already occurred. This is why inelastic buckling is so common in everyday engineering. When a load causes parts of the member to yield, the effective stiffness drops. The structure becomes less able to resist buckling, so it fails sooner. Manufacturing imperfections also play a role. Small flaws or residual stresses from welding or fabrication can cause local yielding even before the load gets very high. These imperfections act like weak spots, making the structure more prone to inelastic buckling. As the load increases, these weak spots deform first, leading to a gradual, nonlinear response. This gradual failure process is typical in shorter, stockier columns where the material yields before the structure suddenly buckles. In practical applications like steel columns in buildings or bridge supports, inelastic buckling often governs how much load the member can carry. Engineers use special formulas to predict these loads because the classic elastic buckling formulas don't work well once yielding starts. Instead, they relying on advanced theories that account for the material's plastic behavior. The reason inelastic buckling is so common is that many structures operate in a zone where stresses are high enough to cause some yielding but not enough to crush the material completely. This combination leads to buckling at lower loads than simple elastic calculations suggest. It's a failure mode that engineers must always keep in mind to design safer, more reliable structures.